Hello and welcome to my fifth and final video on naming and formula writing. In this video, what I'd like to do is show you how to take all of the previous systems I've used, the rules for ionic naming, the rules for acid naming, the rules for binary covalent, and the hydrates, which went along with the ionic, and just how to use them and how to know when to use which system. If you have any questions about details on each system, you'll want to go back to the previous videos, which explained them individually and gave you some examples. This is just so you can see when they're all mixed up, how do you know which system to use. So let's start right here. I have some formulas written on the left side, and what I want to do is go from formulas to names. Well, how do I do that? Well, what I want to do is I want to look primarily at the first element. In this case, this is a metal. Metals, if you remember from your periodic table, are to the left of that stair-step line. And so what happens is this is a metal. This happens to be tin. Sn is the symbol for tin. The Sn comes from the Latin name for tin. And so this is tin, and this is oxygen. And again, remember when we have single elements, we change the ending to IDE. So this would be tin oxide. If you recall, with ionic compounds, I said your one question is, do I need a Roman numeral? And if you look on your periodic table or some other resource, you're going to find that tin can be either a +2 or +4 charge. So I need to know which one. So what I'm going to do is I'm going to go back and say, well, listen, oxygens, they're -2. This whole thing has to add up to 0. So what would have to be the charge of my tin? So the combined charge would be 0, and of course that has to have a +2 charge. So then this, of course, is going to be tin 2 oxide. So I put that in there. The reason I knew to do this ionic is because this first thing was a metal. Okay. Now notice here, my first thing is an H. That means I do the acid naming, and if you recall, we said with the acid naming, you base the name on the anion, the second thing. Well, what is this called? Well, a ClO would be called a hypochlorite, and so what ends up happening is ites, we said, become us acid. So this would become hypochlorous acid. And again, the reason is because we always base the acid names on the second thing. H lets me know I'm going to use the acid naming, but then I base the name on this guy and how it ends. It ends in ite. We said ite becomes us acid, so I took the hypochlorite ion, got rid of the ite, and just put us acid on there. Now this third one, this was a metal, so I did ionic. This was an H, so I did acid. This P is to the upper right, it's phosphorus, it's to the upper right of the line. This is a non-metal. Since this is a non-metal, I'm going to use the binary covalent system where the prefix for 2 is di and P is phosphorus, so this is going to be diphosphorus. And then penta was the prefix for the 5, so this is going to be pentoxide. Okay, and so I used all three different systems here, but the one I used was dependent on what the first element was. When you get to these things, remember these were hydrates, we said, and what happens with a hydrate is this first thing will always be ionic. So Fe is iron. NO3, if you look on a reference packet somewhere, is a nitrate. And then I'll do this part last, but one thing with ionic is, do I need a Roman numeral? And you'll notice nitrates are -1 each. I've got 3 of them, so I have a total of -3 charge. So then for my whole thing to add up to 0, this positive area has to be +3. It's only coming from one iron, so that one iron has to be iron 3 nitrate. So I've named the first part, and now with this you just add a prefix in the word hydrate. The prefix for 9 was nana, so this is going to be iron 3 nitrate nanohydrate. Okay, and so that's all you would do. So that's how you do the hydrate naming. Now going backwards, if I give you the name and you have to do the formula, you just do everything backwards. So this is hydrobromic acid. Well, the hydro, if you remember from the acid naming video, hydro means that this ended in ide. My anion ended in ide. So what's a bromide? Remember IDE endings like that, oftentimes, particularly when it refers to an element, are just a single monatomic anion. Bromine ions are -1. And again, since this is hydrobromic, it's based on the bromide ion. Ide is coming from bromide, means it's the single element. Since they're -1, the H would be +1, so I just need 1 of each. So this is going to be HBr, and so that's hydrobromic acid. Carbon disulfide, this is a non-metal. It is to the upper right side of the line, so I'm using these prefixes. There's no prefix on this first one, so that means there was only one carbon. Di is the prefix for 2, so that means there were 2 sulfurs, so that's going to be CS2. Calcium selenide, okay, calcium is in the second column. It's an alkaline earth metal, so they're +2 always. Selenide, remember this "ide" helps me recognize that this is from the element selenium. Selenium is below oxygen. It's in group 16 of the periodic table, so it has, and let me put the symbol, it's Se, and it's -2. So +2, -2, these both add up to 0. So my formula is CaSe. Coming down here, sodium carbonate monohydrate. Here's one of these hydrate things, so that means I'm going to have to do it kind of like this one over here. So I have to write the first part ionically. Sodium is +1. If you look or know, a carbonate is CO3 and it has a -2 charge. For these to add up to 0, of course, I'm going to need 2 sodiums for a +2 to cancel out this -2. So my formula for the sodium carbonate is going to be Na2CO3. And then for monohydrate, I just do dot, and you don't write the 1, you would just write H2O. Now if it was dihydrate, I'd do 2H2O, trihydrate would be 3H2O, and so forth. So this is how, when you have mixed names and mixed formulas, how you tell the difference and how you follow those rules for naming them. All right, thank you very much.